Welcome to a new episode from Aurora Knowledge. Today, we're taking a journey into one of the most fascinating frontiers in modern science: quantum research. At the center of our story is NASA's Cold Atom Lab aboard the International Space Station, or ISS. This remarkable laboratory is opening new possibilities for studying quantum matter in space, and it could have far-reaching consequences for how we understand the physical world. So what exactly is this project? And why are scientists so excited about it? To understand the importance of the Cold Atom Lab, we first need a quick look at quantum mechanics itself. Quantum mechanics is the branch of physics that deals with the smallest building blocks of matter, atoms and subatomic particles. Unlike classical physics, which describes the motion of larger objects, quantum physics tells us that particles do not simply move along fixed paths. They can also behave like waves. This dual nature leads to astonishing phenomena such as superposition and entanglement. Superposition means that a particle can exist in several states at the same time. Entanglement describes a connection between particles that remains in place regardless of distance. These ideas may sound abstract, but they are not just theoretical curiosities. They already shape the modern world in very practical ways. NASA's Cold Atom Lab, installed on the ISS in 2018, is a highly advanced experimental facility designed to cool atoms to extremely low temperatures, close to absolute zero. At these temperatures, atoms begin to behave in ways we cannot observe under normal everyday conditions. They can form what is known as a Bose-Einstein condensate, a state of matter in which large numbers of atoms enter the same quantum state. One way to picture this is to imagine a huge group of dancers moving in perfect synchrony, all following the same rhythm in complete harmony. That image of synchronization is not just poetic. It helps illustrate why this state is so valuable to researchers. It allows them to observe quantum behavior on a scale that is easier to study. One of the Cold Atom Lab's greatest advantages is the microgravity environment on the ISS. These conditions allow scientists to perform experiments that would be difficult, or in some cases, impossible, on Earth because of gravity. In weightlessness, researchers can study interactions between atoms and other particles with greater precision and gain a better understanding of the properties of quantum matter. This could lead to discoveries that deepen our knowledge of the fundamental laws of the universe. One example is the study of ultra-cold atoms and how they behave in different quantum states. Scientists use lasers to cool the atoms and then hold them in a special magnetic field. This allows the atoms to be observed for longer periods, and their interactions to be analyzed more carefully. The results of these experiments may do more than expand our understanding of quantum matter. They could also inspire new technologies based on these principles. One especially promising area is quantum computing. In theory, quantum computers could solve certain complex problems much faster than conventional computers by making use of quantum mechanical effects. Imagine quantum computers helping to accelerate medical breakthroughs or simulate extremely complex climate models, potentially improving our ability to respond to the challenges of climate change. The possibilities are enormous, and research in this field is still only beginning. A particularly surprising aspect of quantum research is the possibility that quantum phenomena may be widespread in nature and not limited to subatomic particles alone. Some scientists believe quantum mechanics may also play a role in biological systems, for example, in photosynthesis or in the navigation behavior of birds. However, this remains the subject of intense research and debate. If quantum effects do turn out to play an important role in biological processes, that could transform our understanding of life and evolution. It might also have major implications for biology and medicine. Such findings could point the way to new strategies for combating disease or improving the efficiency of energy conversion processes. There is also a common misunderstanding that quantum mechanics only matters to physicists and has no influence on daily life. In reality, quantum mechanics has already led to many technologies we use all the time, including transistors, lasers, and modern computers. These inventions are built on quantum principles and have completely changed our world. Future progress in quantum research could lead to even more transformative technologies. One example is quantum communication. Based on the principles of entanglement, it could make the transfer of information more secure and potentially more efficient. This is especially relevant in a time when data breaches and cyber attacks are becoming more common. Quantum communication could allow information to be transmitted in a way that is more secure than anything available so far. In the future, it may play a key role in cybersecurity, helping protect not only companies but also individuals from the risks of the digital age. Another fascinating area is quantum entanglement itself, a phenomenon the Cold Atom Lab may help illuminate further. Entanglement allows two or more particles to remain linked regardless of the distance between them. If the state of one changes, the state of the other changes instantly as well, no matter how far apart they are. This strange property challenges our intuitions about space and time, and it may also enable practical applications in quantum communication and quantum computing. One possible application is the development of quantum networks that could support secure communication between different locations. In a world of increasing cyber attacks and data leaks, quantum communication could offer a revolutionary solution. By using entanglement, information might be transmitted in such a way that any attempt to intercept it would be detected immediately because the state of the particles would be disturbed. That could be important not only for businesses, but also for governments and organizations that need to protect sensitive information. Another exciting field is quantum metrology, which could take measurement precision to a whole new level. With ultra-cold atoms and the unique conditions inside the Cold Atom Lab, scientists may be able to develop new standards for time measurement and other physical quantities. Advances in this area could support fundamental research, but they may also have practical uses in navigation, communication, and even medical diagnostics. At the same time, it is important to remember that quantum research also comes with serious challenges. Quantum mechanics is inherently complex, and carrying out experiments in microgravity requires highly innovative approaches and specialized technologies. Scientists must not only understand the underlying theory, but also develop practical solutions to make these experiments work. Research in this field is often slow, demanding, and dependent on patience and interdisciplinary collaboration. There is also an ethical dimension that should not be overlooked. As quantum communication and quantum computing advance, questions arise about how these technologies should be used responsibly. The ability to transmit information with extreme security could have both positive and negative consequences. That is why it is crucial for scientists and decision-makers to keep these issues in mind as new technologies are developed. In the end, NASA's Cold Atom Lab is more than just a laboratory for studying quantum matter. It is also a catalyst for future technologies and applications. The insights gained from these experiments could affect many areas of life, from improved cybersecurity to new medical technologies. The potential is enormous. As we continue exploring the mysteries of the quantum world, it is worth recognizing both the scientific importance of this research and its possible benefits for society. Quantum research may not only deepen our understanding of the laws of the universe, it may also help provide solutions to some of humanity's most pressing challenges. If you enjoyed this episode, subscribe to Aurora Knowledge, turn on notifications, and let us know in the comments which topic we should explore next.